The National Mathematics Day is celebrated on 22nd December every year to mark the birth anniversary of the prominent Indian mathematician Srinivasa Ramanujan. It was on this day in 1887 the Indian mathematical genius Srinivasa Ramanujan was born. The mathematical genius Ramanujan was born to a Tamil Brahmin Iyengar family at Erode, Tamil Nadu. Even though he did not have any formal education in the field of mathematics, today he is considered as the man who knew infinity. Now let's look at some of his important contributions. Ramanujan compiled around 3,900 results consisting of equations and identities. One of his most treasured findings was his infinite series for pi. This series forms the basis of many algorithms we use today. 1729 is known as the Ramanujan number. Ramanujan's contributions stretch across mathematic fields, including complex analysis, number theory, infinite series, and continued fractions. He elaborately described the Mach theta function, which is a concept in the realm of modular form in mathematics. And in order to honor him this day, let's look at some real-life applications of different topics coming under mathematics. First, let's see real numbers and its applications in daily life. Before getting into real numbers, we must know what number systems are. Number system is defined as a system of writing to express numbers. It represents numbers of a given set by using digits or other symbols in a consistent manner. It allows us to operate arithmetic operations like addition, subtraction, multiplication, and division. Now let's move on to real numbers. Do you know what a rational number is? A rational number is a number that can be written in the form p by q, where q is not equal to 0. Some examples of rational numbers are 7, minus 21, 11 by 2, 0.01. And irrational numbers are numbers that cannot be written in the form p by q. Some examples are pi, root of 27, root 2, root 3. Now, real numbers are the collection of both rational and irrational numbers. Real numbers are represented by the letter capital R. Now, where all do we use real numbers? Let me tell you one thing. Majority of calculations that we do include real numbers. Here I'm mentioning only 5. Applications of real numbers can be seen during food shopping, for monetary purposes, mechanical purposes, for cooking, and meteorological purposes. Now let me explain the first 3 categories mentioned. Let's start with a simple one. The first category mentioned was food shopping. The question is, Jin wishes to buy 25 kilograms of bananas from a local supermarket. If one bunch of bananas weigh 5 kilograms, how many bunches of bananas should Jin buy? From simple calculations, we are able to find out that Jin will have to buy 5 bunches of bananas. If we observe all the quantities given, we can say that they are all real numbers. Most commonly, we use real numbers for calculations regarding monetary purposes. Here I take an example. Rishabh takes a loan of rupees 10,000 from a bank for a period of 1 year. The rate of interest is 10% per annum. Find the interest and the amount he has to pay at the end of a year. As I have mentioned earlier, real numbers are the collection of both rational and irrational numbers. If we observe all the quantities that we are given, we can see that all of them are rational, hence are real numbers. Here, by applying different arithmetic operations, we will arrive at the answer, that is rupees 11,000. Lastly, we can see the application of real numbers in various mechanical purposes. This can be to find speed of an object, the distance traveled by an object, the time taken to cover a particular distance by the object, and hence we arrive at this example. The speed of a bus is 24 kilometers per hour. How much distance will it travel in 12 seconds? The answer to this question also includes calculations of real numbers. Here, by using the formula speed is equal to distance by time, we arrive at the result distance is equal to 80 meters. Now, let's summarize. Real number is any number that can be represented on a number line or by an infinite decimal expansion. It is the collection of all rational and irrational numbers. And there are uncountable situations in our daily life where we use real numbers.
Mathematics in daily life. Application of geometry. Introduction. What is geometry? Geometry is one of the classical disciplines of maths. Roughly translating it in Greek as earth measurement is concerned with the properties of space and figures. Practically, geometry plays a great role in determining the area, volume, and length. And Euclid is considered to be the father of geometry. Index. Let's discuss some important examples of geometry which do not fail even a single chance to play a pivotal role in the daily life of humans. Nature, technology, homes, art, and architecture. First of all, let's see how nature plays an important role in geometry. Nature. The most important example of geometry in everyday life is formed by the nature surrounding humans. Different geometrical shapes and pattern is observed in leaves, flowers, stem, root, bark, and etc. The leaves on the trees are of varying shapes, size, and symmetries. One of the examples that points out here is the honeycomb with a hexagonal pattern. Now, let's look on to the next property, that is the technology. Computer programs work under the concept of geometry. Be it robotics or computers or video games, geometry is applied to almost all the underlying concepts. The virtual world of video games is created only because the geometric computation helps in designing the complex graphics of the video games. Raycasting, the process of shooting, employs a 2D map for simulating the 3D world of video games. One of the notable examples for technology is that of the robotics. Next, there comes homes. Geometry does not leave even a single chance to play a significant role in home as well. Geometric patterns are found in every household items like the windows, bed, chair, bed sheets, rugs, etc. The decorative pieces in homes like the vases and the paintings possess different geometric shapes and patterns. Even while organizing a room, each and every space is utilized to make a room look more appealing. Now let us look on to art, which plays a crucial role in geometry. What does art include? Art encompasses the formation of figures and shapes, a basic understanding of 2D and 3D, a knowledge about conceptual space. The contents of painting and sculptures are largely affected by the choice and the shapes of frames. From the aforesaid, it is evident that there is a close relationship between art and geometry. The formation of shape is a result of the use of geometrical forms like circle, triangle, square, mandala, or the octagon. Moreover, the contents of paintings and sculptures are largely affected by the choice and shapes of frames. Not to forget that the principles of projective geometry from the basis of perspective, which is used in almost most of the paintings. By the end, we come up with the last application of geometry, that is the architecture. The construction of various buildings or monuments has a close relationship with geometry. Before constructing architectural forms, mathematics and geometry help put forth the structural blueprint of the building. The theories of proportions and symmetries shape the fixed aspects of all kinds of architectural designs. Not only were the basics of mathematics coupled with the geometry helped in increasing the aesthetics, harmony, and the religious value of large structures, but also aided in mitigating various hazards resulting from high speed winds. Moreover, the staircase in buildings take into consideration the angles of geometry and are constructed at 90 degrees. Conclusion. As we conclude, Geometry has always been a part of the daily lives of the human beings. From our houses,
Thank you, Deebajali. Now let's move on to the next topic.
Now we are going to discuss the applications of trigonometry in real life. We all know that trigonometry is the branch of mathematics that deals with specific functions of angles and their applications. There are basically 6 functions of an angle commonly used in trigonometry, which are sine, cosine, tangent, cotangent, secant, and cosecant. It was Hipparchus, a Greek mathematician, who first formed a table for trigonometry and thus is regarded as the father of trigonometry. So here are some of the applications of trigonometry in real life which we are going to discuss now. It is mainly used to determine the height of a building or other tall objects. It is also used in the fields of aviation, criminology, marine biology, and in navigation. Firstly, the use of trigonometry in measuring height. It is used to measure the height of a building or other tall objects like a mountain. So, with the distance of a building from the viewpoint, that is where the viewer is standing, and the elevation angle, we can easily determine the height of a building using specific trigonometric functions. For instance, if the distance from the building is 90 feet and the angle of elevation is 35 degree, then the height of the building can be easily found out using the trigonometric functions. That is, tan theta is a trigonometric function which is opposite side upon adjacent side. So here the equation can be formulated as tan 35 degree is equal to h upon 90. Thus the height of the building can be found out as 63 feet. Next comes the use of trigonometry in the field of aviation. Aviation technology has evolved so much in the last few years with many upgradations being made. It has considered many factors like speed, direction, distance, as well as the motion of the wind in determining how a flight will travel. This industry extensively uses the knowledge of trigonometry for that. To estimate distances, landing patterns, and navigate around obstacles in the sky, trigonometry and its various functions are used on a wide scale here. Let us consider an example. If an aeroplane is traveling at 250 miles per hour, 55 degree of north of east, and the wind is blowing in southward direction at 19 miles per hour. This calculation can be solved using trigonometry to find the third side of the triangle, which will lead the aircraft in the right direction as it is. Another application of trigonometry is in the field of criminology. It is mostly used in the investigation of a crime scene. Forensic scientists and investigators use trigonometric functions and equations to deduce what might have happened at a particular crime scene. They analyze blood splatter along with analyzing bullet holes to determine the angle of impact on the victim, and the use of technology of navigation to pinpoint a criminal's location. Furthermore, trigonometry can be used in criminology. They can help to calculate a projectile's trajectory to estimate what might have caused a collision in a car accident. It also helps to find how an object has fallen from a height or at what angle was a bullet shot. Thus, to conclude, those who are seeking a career in criminology or crime scene investigation must have a solid education not only in science but also in mathematics. Now, the trigonometry in marine biology. Marine biologists often use trigonometry to figure out various things. For instance, they figure out the depth of sunlight that affects algae to perform the process of photosynthesis. Quite interesting, right? They also use trigonometric functions and mathematical models to estimate the size of larger animals like whales from the distance and understand their behaviors. In marine engineering, trigonometry is also used to build and navigate marine vessels. To be more specific, it is used in the design of marine ramp, which is a sloping surface to connect lower and higher level areas, or even a staircase depending on its application. Trigonometry is also used in navigation. It is used to set directions such as north-south or east-west. It tells you at what direction to take with the compass to get in a straight direction. With trigonometry, navigation in order to pinpoint location is also possible. We can also find the distance of the shore from a point in the sea. We know that Earth is approximately a sphere, so one standing close to it can only see a limited area. So this forms a circle with the observer as the center. This circle is called the horizon. Further, trigonometry can also be used to see this horizon.
That was very informative. Thank you, Mahadevan. Now let's see who's next.
Statistics is a process to convert data into a set of equations that can help us solve problems. This science can help us understand our past and make predictions about the future. Using statistics, we can analyze data in different fields to monitor changing patterns, then use this analysis to draw conclusions and make forecasts. News reports on health and disease often cite statistics starting the devastating impacts on population. If the news simply reports the number of people who either have the disease or who have died from it, it is an interesting fact. However, it might not mean much to your life. When statistics become involved, people have a better idea of how that disease may affect them personally. For example, the World Health Organization reported that the number of people with diabetes has risen from 108 million in 1980 to 422 million in 2014. The WHO reported that diabetes was the seventh major cause of death in 2016. These studies suggest that 85 to 95% of diabetes cases can be prevented by eating a healthy diet, having regular physical activity, and maintaining normal body weight. There is lots of uses of statistics in sports. Every sport requires statistics to make the sport more effective. Statistics help the sport person to get the idea about his or her performance in the particular sports. Statistics is used to get a conclusion from the given data. For example, the Tokyo Olympics were postponed because of COVID-19. Statistics help in understanding that the majority of Japanese were affected in the planned Olympics duration. Therefore, they were able to postpone it and reschedule it for July 2021. Statistics play a crucial role in weather forecasting. The computer used in weather forecasting is based on the set of statistics functions. All these statistics function to compare the weather condition with the pre-recorded seasons and conditions. This helps the government. Let's take an example of our practical life. Suppose you are planning a 2-day family trip to a hill station, and we went there with the family as per the plan. But it's been raining continuously for 2 days and you did not enjoy your trip. What will be your reaction? Definitely, you will be upset rather than being happy. What's the solution then? Don't worry. The blend of technology and statistics make it possible to know the weather of a particular place with a graph that indicates it's a rainy, sunny, or a normal day. So when we plan to travel anywhere, we can check the weather conditions, whether they are normal or not. By doing so, you can save time and energy. For weather forecasting, predictors use the concept of probability and statistics. They employ several concepts and tools to predict maximum accuracy for forecasting. Statistics can help us in managing our finances. It helps us to analyze our monthly budget and therefore gives us an awareness about when and where to spend money. It helps to compare expenses in different months. Now, suppose your expenses increase unusually in a month. You will be able to take necessary steps to avoid it next month by reducing unnecessary expenses. It can also help in analyzing high spending areas and thereby reduce expenditure in those areas.
That was very well said, Balagopal. Let's move on to the next.
Set. A set is a collection of elements or numbers or objects. Set theory in daily life. Now we're going to see some of the applications and uses of set theory in real life. Kitchen. Kitchen is the most relevant example of set theory. In kitchen, we organize everything in different sections which will make it easy to access. Playlists. We all listen to music, so we know the use of playlists in our daily life. We make playlists based on different factors about songs such as artists, genres, etc. This is an example of set. Library. When we visit a library, we don't see lost in a heap of books. This is because the books in a library are arranged by different categories such as novels, non-fictions, fictions, etc., which is an example of set. Universe. Yes, the universe itself is arranged on a specific manner. Different galaxies are separated from each other due to their specific properties. Different parties in a parliament. When we see the parliament on TV, we notice that the members of parliament are sitting in definite order by their parties. This is an example of set 2. School bags. If we want to know the daily life applications of sets, we just have to check our school bag. Students arrange their books accordingly of each subject. Also, textbooks and notebooks are kept separately, which is an example of set.
That was a whole lot of good information, Meenakshi. Thank you. And last but not least, let this day remind everyone that everything around us is connected to mathematics. It shows us that every problem has its own respective solution. And hence, we should honor those who made tremendous developments to the field too. Have a great day. Thank you.